Dear participants, good morning to all of you. Greetings from Xavier's Catholic College of Engineering, Nagercoil. In this pleasant morning, I am happy to welcome you all for the fourth day of the one-week hands-on workshop on data science using R. This program is jointly organized by the Department of Computer Science and Engineering and the Department of Information Technology of St. Xavier's Catholic College of Engineering. In the first 3 days, we discussed about the basic of the R programming. There is R basic, variables, data types, operators, names, missing values, control structures, functions, strings, subsetting R objects, file connection, R chart, and graphs. These are the things we discussed for the last 3 days. Today we are going to enter in the real-time application of R, that is introduction to machine learning. Today we are going to discuss. Then supervised learning, implementation of classification and regression algorithms using R. These are the things we are going to discuss today. Before going to the presentation, I like to remind few instruction participants. Please mute your mic to avoid the disturbances during the. Also, I request you to switch off your camera to reduce the internet data usage. After the talk of the guest speaker, you can ask your queries by place. You can type your questions in the chat window and the speaker will address the queries, or you can make a hand raise and ask your queries. At the end of today's session, there will be a simple assessment will be there and a feedback session also. We already shared the recorded videos and the PPTs in the official webpage of the workshop. The link was already shared to you. Today also I will be sharing the link. Now, I like to introduce today's speaker, Mrs. M. Geetha Jenifel. Mrs. M. Geetha Jenifel was graduated in Information Technology in 2005 from Anna University, Chennai. She obtained her ME degree from Anna University, Tirunelveli in 2010, specializing in computer science and engineering. She was pursuing PhD degree under Anna University and submitted the thesis and waiting for the final Viva Voice process. She is in the teaching profession for the past 10 years. Currently, she is working as an assistant professor in Information Technology Department of St. Xavier's Catholic College of Engineering, Nagercoil. With this brief introduction, I invite Engineer M. Geetha Jenifel to start today's session. Welcome, madam.
Welcome, sir. Thank you for your introduction, sir. So, very good morning to one and all present here. So, I'm Geetha Jenifel. I am working in assistant professor in the IT department in St. Xavier's Catholic College of Engineering. So, I think you are all having very good idea in last 3 years. You gather more points in our programming. So last 3 days, Pamela ma'am has presented variables, data types, control structures, graphics like that. So today I am going to present the topic machine learning using R. So topics of discussions are introduction of machine learning. Then I'm going to tell about types of machine learning, 3 important types. Then among the 3, I am going to explain supervised learning algorithm. So comes under the supervised learning algorithm, 2 concepts are there, that is regression and classifications. Later we will discuss one by one. So first, the term machine learning was first coined by the author Samuel in the year 1959. So you know that machine learning is the most in-demand technologies in today's market. So its applications range from self-driving cars to predicting deadly diseases such as ALS, that means death of neurons. So, and also around the world, we have been generating an immeasurable amount of data. So recently one research is there. That is, the research says we generate around 2.5 quintillion bytes of data every single day. That means 1.7 megabyte of data will be created every second for every person on earth. So with this availability of so much data, the humans, they are not able to extract useful information among the huge information. So one solution is there, that is to build a predictive model that produce more accurate results by analyzing the complex data. So in this case, the machine learning enters here. So they simply say that the definition for machine learning is which provides machines the ability to learn automatically and improve from experience without being explicitly programmed to do. So here, listen, we can simply say that the machine learning is about making computers modify or adapt their actions. Here, actions are either making prediction or controlling a robot. So the next year, I'm going to tell about need for machine learning. So many reasons are there. First reason is increase in data generation. I already told you, so that is every person generating a huge amount of data, and every day, every second. So due to excessive production of this data, we need one model that used to structure, analyze, and draw useful information from that data. So here, for that, we need to build one model. So this is where machine learning comes in. This model uses data to solve problems and find a solution. The second one is the improve decision making. Second one, improve decision making. So with the help of various machine learning algorithms, it produces a better decision. These are used in the business or organization peoples. For example, the machine learning is used to forecast sales and predict downfalls in the stock market, and also identify risk and anomalies, etc. So various machine learning algorithms are there. That algorithms are used to generate a successful decision. So the third one is the uncover patterns and trends. So here, understanding data and extracting patterns manually, it will take more days. So the machine learning algorithms can perform such computation in less than a second. So the last one is the complex problems. So I already told you, so the applications are range from self-driving cars and detecting the genes linked to the deadly diseases. So these are the complex problems. With the help of machine learning algorithms, we can use to solve them, solve these type of complex problems. The next one is the applications of machine learning algorithm. And so you heard about the Netflix. So it is one of the famous recommendation engine. So in our day-to-day life, over 75% what we watch is recommended by Netflix. So in a machine learning, one important algorithm is there, that is supervised learning. One important technique, that is unsupervised learning. So comes under the unsupervised learning, clustering concepts are there. This Netflix recommendation system is implemented based on that clustering concept. Second one is the Facebook's auto tagging feature. So in this case, the machine learning neural network concept is used. And also one that is DeepMind is there. So it studies the facial features in an image to tag your friends and family. So the next third one is the Amazon's Alexa. So here, with the help of this, we can book Uber, then connect with the other IoT devices at home, and also we can monitor our health also with the help of Amazon Alexa. Then the last one is the Google spam filter. So with the with the help of machine learning, Gmail make use to filter out spam messages. Many machine learning algorithms and natural language processing are there to analyze emails in real time and classify them as either spam or non-spam mail. So these are the applications of machine learning algorithm. The next slide, I'm going to talk about some important terminologies we use in a machine learning algorithm. Here the first one is the algorithm. So machine learning algorithm is a set of rules and some statistical techniques. These are used to learn patterns from data and draw some useful information from it. So an example of some machine learning algorithms are linear regression algorithm, then classification and regression trees, neural network, k-nearest neighbor algorithm. So many algorithms are there. So the second terminology is model. So the model is the main component of machine learning. This model is trained by using a machine learning algorithm. And also an algorithm map all the decisions the model is supposed to take based on a given input in order to get the correct output. So model take a given input and produce the producing for a correct output. So the third one is the predictor variable. So it is the features of the data. For example, to implement the machine learning algorithm in R, we need a data set. So data set has many features. For example, assume one data set that is Irish. In an Irish data set, totally 5 attributes are there. Petal width, petal length, sepal width and sepal length. With the help of these 4, we can able to classify the unseen data belongs to which species, whether it is a family or whether it is a set of soil like that. So here in this data set, in the Irish data set, petal length, petal width and petal width, sepal length and sepal width, these 4 are predictor variable. That means it is the features of the data. These 4 can be used to predict the species of the particular flower. So simply we can say that predictor variable is an input variable. These are used, that can be used to predict the output like that. Next one is the response variable. So it is a feature or it is a target variable or output variable that needs to be predicted by using the predictor variable. So response variable means simply we can say that in our data set, species is the response variable. All other 4, that is petal width like that, that are predictor variable. So the next one is the training data. So in a machine learning model, model is built using the training data. This training data helps the model to identify the patterns essential to predict the output. So for training data, it helps our model to identify the pattern that are essential to predict our output. The next one is important term, that is testing data set. That is testing data. After a model is trained, it must be tested to evaluate accuracy of our prediction. So to find the accuracy or to perform the evaluation, we use the test data set. So simply we can say that it must be after the model is trained, it must be tested to evaluate accuracy of prediction, accuracy of our prediction. Can we predict an outcome? This is done by the testing data set. So these are the important terminologies used in machine learning. So next one is I'm going to talk about machine learning process. So machine learning process, the main concept is to build a predictive model that can be used to find a solution. Model that can be used to find a solution for a given problem statement. So for that, many important steps are there. First one is define the objective of the problem statement. At this step, we must understand what exactly needs to be predicted. In our case, the objective is to predict the possibility of rain by studying weather conditions. At this stage, here we note that so what kind of data can be used to solve this problem, or the type of approach we must follow to get the solution. So during the first step, first thing is we must understand what exactly needs to be predicted. So to explain this slide, I am going to talk about one data set, that is predict the possibility of rain by studying some weather conditions. So for that, some attributes are there, that is humidity level, temperature, pressure, like that. So at this stage, data can be what kind of we have to note it, what kind of data can be used to solve this problem, or the type of approach we must follow to get the solution. So the second one is the data gathering. During this stage, we have to answer some question. What kind of data is needed to solve this problem? Second thing is the data are available, or how can we get the data, like that. Once we know the types of data that is required, we must understand how we can derive this data. In our case means to predict the possibility of rain. The data are, some features are there. Humidity level, temperature, pressure, then locality, whether we are live in a hill station or not, etc. Such data must be collected and stored for analysis. So these are all comes under the data gathering. So data gathering, we are ready to answer what kind of data is needed to solve the problem. Second one is the data are available, or how can we get the data, like that. The third step is the data preparation. So the data what we collected in the previous step is almost never in a right format. So we will encounter a lot of inconsistency in the data set. That means missing values. That means null values, and also redundant variables, and duplicate values are there. So we are responsible to removing such inconsistencies, very essential. Suppose the in data set it has inconsistency, means it leads to wrongful computation and our prediction. So during data preparations, we are concentrate more about avoiding inconsistencies, what we present in our data set. Inconsistency means, once again, missing values, redundant variables, and duplicate values like that. The next one is the exploratory data analysis. That means data exploration. So here, during this step, it involves understanding the patterns and trends in the data. At this stage, we know about the correlation between the variables. So if there are two features, that means petal length and petal width, the choose are input variables. In this step, we are analyzing the correlation between two inputs like that. So this is the fourth step. So next one, fifth one is the building a model. So here, to build a model, we have to concentrate two things. So at this stage always begins by splitting our data set into two parts. One is training data, another one is the testing data. You know that the training data is used to build and analyze the model. So the logic of this model is based on the machine learning algorithm that is being implemented. So in our case, we are going to predict the rainfall. So in a rainfall, the output will be in the form of true or false. That means if it will rain on, it will rain on tomorrow, or false means no rain on tomorrow. So for this case, we can use the classification algorithm, such as logistic regression. Logistic regression is one of the classification algorithms. So here we are going to predict true or false. The true means if it will rain on tomorrow. False means no rain on tomorrow. So in this case, we are going to use classification algorithm. One example for classification algorithm is logistic regression. So choosing the right algorithm, so it depends on the type of a problem we are trying to solve. It depends on the data set and the level of complexity of the problem. So depending upon the data set and level of complexity of the problem, we need to prefer the machine learning algorithm. So in a build model, you have to concentrate two things. We need to split the data set into two things. One is the training data set, another one is the testing data set. Here, the training data set is used to build the machine learning model. Then, next step, model evolution and optimization. After building a model by using a training data set, it's the time to put the model to a test. Here, testing data set is used to check the efficiency of the model. That means how accurately it can predict the outcome. So in this scenario, test data set is used. So finally, the last step is prediction. So once the model is evaluated and improved, it is finally used to make some prediction. So here the final output can be a categorical variable or it can be a continuous variable. Categorical variable means true or false. Continuous quantity means the predicted value of a stock market, like that. So in our case, for predicting the occurrence of rainfall, here the output will be a categorical variable. So these are all about the machine learning process. The next one is the next slide. So I am going to say about one data set. So this is a data set for a person whether purchase a given item or not. Either item may be either a computer or anything. So for that, here nation, purchase item, age and salary. So in this data set, the purchased item is a target variable, that is a response variable, and age, salary, nation are the input variables. So here the one cell is there that is marked as a green color, so that is called as an null value. That means at that time the values are not equivalent to 0, so it represents the null value. So this is an example for one data set. So next, we enter into a types of machine learning. So in a machine learning, 3 types of learning algorithms are there. First one is the supervised learning. Second one, unsupervised learning. Third one is the reinforcement learning. So better understanding, first I am going to tell about supervised learning algorithm. So in a supervised learning algorithm, so our students are, our example for supervised learning algorithms are, our students, they're expecting some guidance to solve some mathematical problems. The other teachers help them what addition is and how it is done, like that. Similarly, the supervised learning, it involves a guide. That means the labeled data set is the teacher that will train us to understand pattern in the data. So the labeled data set is nothing but a training data set. So here one diagram is there. So in this diagram, so here we are feeding the machine, feeding the images of Tom and Jerry to the machine. So here the main goal is for the machine to identify and classify the images into 2 groups. Here listen, the labeled data, the inputs are labeled. So here I am telling about this is the image for Tom. Second also image for Tom. Then this is the image for Jerry, like that. So the training data that is feed to the model is labeled. That means we are telling the machine that is, this is Tom and this is Jerry, like that. Here, training the machine by using labeled data. So in a given input, we are providing labeled data. So that is, we are providing one guide to predict the labeled output. So in a supervised learning, correct response is provided. So all the classification and regression algorithms are comes under this supervised machine learning algorithm. The second one is the unsupervised learning. So listen this slide. Here unsupervised learning, assume some smart kid that learns without any guidance. So in this type of machine learning, the model is not fed with labeled data. That means in the model has no clue that this is this image is Tom and this is Jerry, like that. It figures out pattern and the difference between Tom and Jerry, or it's won by taking in data. So for example, machine, in this algorithm, machine, it identifies prominent features of Tom, such as pointy ears, bigger size, like that, to understand that this image is of type 1. So therefore, it classifies the images into 2 different classes without knowing who's Tom and who's Jerry, like that. So the main concept of unsupervised learning is correct response are not provided. All the clustering algorithms comes under this unsupervised learning. In a previous slide, I told to you that is Netflix recommendation system. So the Netflix recommendation system comes under this unsupervised learning. Next one is the reinforcement algorithm. So in a reinforcement algorithm, so imagine one situation. So imagine that you were dropped off at an isolated island. What would you do? Panic? Yes, of course. Initially we all would, but as time passes by, we will learn how to live on the island, and we will explore the environment, understand the climate condition, type of food that grows there, then danger of the island, etc. This is exactly how reinforcement learning works. So it has one agent. So in our case, we are the agent because we are stuck on the island. Then that is put in an unknown environment. Unknown here, the unknown environment is island, where we must learn by observing and performing actions that result in rewards. So in the reinforcement algorithm, gets told when the answer is wrong, but it does not get told how to correct it. So the best example for this reinforcement learning are may make real-time decisions and also make some robot navigations. These kind of applications are comes under the reinforcement learning. So this slide, so I am going to talk about the machine learning techniques. Three important techniques are there: supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, the two important classifications are two important types are classification and regression. With the help of regression, we can predict weather forecasting, regression algorithms used in market forecasting, then population growth prediction, like that. Next one is with the help of classification algorithm, we can diagnose a disease, whether the tumor is present or not, whether the tumor is cancerous tumor or not, like that. Then it can be used in image classification and also to identify a fraud detection, like that. So in a second important learning, that is unsupervised learning. In unsupervised learning, so two important concepts are there: dimensionality reduction techniques and also clustering techniques. So in a clustering, concepts are used in the recommendation system. The next one is the reinforcement learning. So reinforcement learning is used in the artificial intelligence games that are implemented in artificial intelligence, that are the reinforcement learning. Then real time, to make the real time decisions, and also robot navigation. These are all important machine learning techniques. So wait a minute. The next slide is types of supervised learning. So two important types of supervised learnings are regression and classification. In a regression techniques, the output is the continuous quantity. That means one real numbers. Example for this one is to predict forecast, to predict the house price. So linear regression is an important algorithm of this supervised learning. The next one is the classification. So here classification, the output is a categorical value. That is whether it is a true or false, or male or female, like that. So here, with the help of classification algorithm, the main aim is to compute the category of the data. You heard about the Irish data set. In the Irish data set, based on the input feature, we are classifying the unseen data into a 3 class, like that. So for classification, the output is a categorical value, like that. So next, we are enter into the regression analysis. So in a regression analysis, an algorithm is used, that is linear regression. It is used to predict the value of a continuous variable y based on one or more input predictor variables. So, one example to explain this concept, I am using one data set that is to predict the house price. So in a house price prediction case, number of bedrooms in a house, then locality, then house size, that in terms of square feet, like that. These are all the input predictor variables. With the help of this input predictor variable, I'm going to the house price. So the house price is a continuous variable in this case. So for that, we need to establish one mathematical formula between the response variable y and the predictor variables x. So more number of predictor variables we can use. The next, the mathematical formula is, you heard about, this y is equal to mx plus c. This is a normal line equations. So this equation can be rewritten like this. Y is equal to theta 1 plus theta 2 dot x. Here, theta 1 is intercept. Theta 2 is coefficient of x. So, to build this regression model with the help of training data set, we need to draw one line. So for that, we find the best theta 1 and theta 2 values. Then only we can able to draw the best fit line. So see this example. So two blue lines are there and one black line is there. So here the black line is best line. How can I say the black line is best line? Here two arrows are there. One is the blue arrow, another one is the blue, two data points. One is represented by blue arrow, another one is represented by red arrow. So here, the distance between these two is small, means we can say that this is the best line. That means simply we can say that I am going to calculate one cost function. Cost function is, that means the difference between the prediction point and the actual point. So in this line here, the actual point is denoted by blue and the prediction point is represented by red, like that. After that, I'm going to calculate the distance between the prediction point and the actual point. The distance between these two is minimum, means we can say that the particular line is best line. So to achieve this, we need to update theta and theta 2 values to reach the best value. So this is the basic concept behind this regression and linear regression algorithms. Now we enter into R program, how we can implement this linear regression in R. So for that, the first step is install and load some libraries. So here I'm going to install one package, that is stat. Stat, that means it's nothing but statistical. It provides some statistical functions. It provides some statistical functions. Then after installing this package stat, we need to import that stat with the help of calling the library function. So first step is install package. The package name is stat. Second, you have to include the library. Then only we can able to use functions. So in this case, I am going to implement regression algorithm. So for that, I am going to use one function, LM function, that is linear model. So this linear model belongs to the package stats, that is statistical package. The second step is import the data set. So here the data set is present in the local drive, so D drive. So it is in a text format. So I used read.delimiter functions. I think you know about this, how to import the data set. Many options are there. That is, we can able to import the data set from the URL or from the Excel sheet, like that. So for that, many functions are used. One important function, scanf. This command is used to read assemble files. But another one command, that is read.tableof. So read.tableof, we can get the data set from the table. Then some files that contain values that are separated by tabs. In that situation, we used this delimiter function, read.delimit. Some data sets are in the Excel format. So for that, we need to use read.csv function. So in a CSV off, one function is there, read.csv off. That means the file contain files that contain values that are separated by comma. Then one more function is there, that is CSV2 off. The CSV off means files that contains values that are separated by semicolon. So I think for understand this concept, it is import data set. Many functions are there. Scan function is used to read symbol files. The second function, read.delimiter. So that means files that contain some values that are separated by tabs, like that. So, then another one function, read.csv. That means files that contain values that are separated by comma. One more function, read.csv2 off. So here, files that contain values that are separated by semicolon, like that. So the first two steps are over. The next one is we're going to studying the data set. For that, we use one function, that is head of data 1. So the data here, one means import the data set and assign the data set into one variable, that is data 1. Here, what is the meaning is, now the data set is available in the variable data 1. In a third step, I'm going to study data set. So for that, I used one function, head of data 1. So after executing this one, the output is in the here the console window. That means the data set has first column ID, second column house style, how many stories are there, like that. Next field, talk about the feet, distance of, sorry, size of our size of the house, the number of bedrooms, then a year of built. Finally says about the sales price. So listen, in this data set, house style, feet, bedroom, year built, these are used as an input. With the help of this, I'm going to predict the price, house price, like that. So for head of data set, this function displays first initial 6 rows. So this is the data set I already explained. So next step, build the model. To implement regression algorithm, next important step is to build a model. So to build a model, here I'm going to implement linear regression. So for that, need to use, I call the function LM. This LM function is available in which package? That is stat package. That is already installed. So here, this LM function, first argument says the formula. That says first one is the predictor variable, that is y variable. Then tilde symbol, then input variable. So here, the first argument says what this means. Based on bedroom and square feet, we are going to predict the sales price. For that, second argument says about the data. The data is available in a variable data 1. After building this model, this result is stored into the variable test 1. The result is stored into the variable test 1. So to build this model, this is the model building model step. So in this step, we are using the training data. That is, we are using our training data. So the next step, that is second step, we are going to declare a data frame. So here, my house, it has 5 bedrooms. The square feet of my house is 2,350. So I am going to predict the price, sales price. So for that, I'm going to build a data frame. So the data frame, it has unseen data. It has unseen data. Now the data frame is constructed and the result is available in data's 1 variable. Data's 1 variable. Now I am going to enter into the next step, that is prediction step. So for predicting the house price, I call the function predict. It has 3 arguments. First one is our model, developed model. So the developed model is stored in the variable test 1. Second argument is the data. So our data set is, data frame. Second one is our data frame. The data frame is available in the data's 1. The third one is the interval. So here, the third argument interval, there are 2 values are there. One is prediction, another one is the confidence. Either prediction or otherwise confidence. Actually, what is the meaning of this one is, confidence reflects the uncertainty around the mean prediction. That means interval is equal to confidence means the prediction based on mean value. But in interval is equal to prediction means it reflects the uncertainty around a single value, like that. So after executing this prediction step, predict function, the result is stored into the variable PRT. Now I am going to display the variable PRT. So our output is like this. That means the first one says about the row, first row. So here our algorithm, the machine learning algorithm prediction is my house price is, that is 25 lakhs 29,261. That is fit. Fit says the prediction. Then lower and upper values are there. This lower stands for, that means the beginning price. The beginning price, it maybe start from 18 lakhs. The maximum means 31 lakhs. This is the output of machine learning algorithm. That is a linear regression algorithm. So this is the output screen. So for that, first you take the RStudio. So to implement this code, so you are asked to go to the RStudio window. Take one new script file. So here I used one data set. The data set is sales.txt. So first we need to import the data set.
Dear participants, there is a small technical issue from the side of Geetha Jenifel madam. It will be rectified immediately. So please be patient. Dear participants, can you see the screen of Madam's computer? Participants, அவங்களுக்கு ஸ்கிரீன் ஷேர் ஆகுது. சரி, ஆர் ஸ்டுடியோ கம்ப்யூட்டர்ல ஆன் ஆகுது இல்லையா? சரி, ஸ்டாப் ஷேரிங் கொடுத்துட்டு திரும்ப ஷேர் பண்ண சொல்லுங்க பாருங்க. ஸ்டாப் ஷேரிங். Dear parents, please be patient. Madam is restarting her computer, so it will take 5 minutes to join Madam again. Geetha madam, is it audible for you?
Yes, sir. I am trying, sir. Wait a minute,
Yeah.
sir.
Madam, now try to share your screen, madam. Madam, now your screen is visible, madam.
And sir, shall I proceed?
Yeah, proceed. Dear participants, sorry for the little disturbance. It is due to the technical issue and the bandwidth issue. Now, madam will be continuing the session. Madam, please proceed, madam.
Sorry, participants. Some problem. I faced some problem in my side. So last I discussed how to implement linear model in our programming. So for that, first you have to install the required libraries, then import the corresponding data set. Third step, study about the data set. Then this slide, it shows the house price data set. It has many attributes, and the final attribute is a sales price, that is the response variable. And then here in this slide, the first step is a model, how to build a model in machine learning. That is, to build a model, I used here as linear LM function. The next step is with the help of unseen data. That means my house, it has a 5-bedroom, and total square feet of my house is 2350. So I build one data frame. The result is available in data swan. The third step, I call the function predict. So I am going to predict my house prices. So for that, I call the function predict. The first argument is model. Developed model is available in test1 variable. Second argument, data frame. Data frame is available in data1 variable. Then third argument is interval. I already discussed about that. So now the prediction result is available in the variable PRT. In a fourth step, I am going to display the variable PRT, what will be present in there, what was present in there. So here the output is based on the previous coding, it produced one output. So the output says the first one is the fit, second one is the lower, third variable upper. So the fit is the correct prediction. That is, my house price is 25 lakhs, 29,000, like that. But lower and upper says the minimum and maximum prediction. That is, the minimum is 18 lakhs. House price start from 18 lakhs, and the maximum is 31,000, like that. So you have a R software, R Studio software. In that, first line says about the importing data set. Second one, knowing about the data set. Third one is the model prediction. Fourth one, data frame development. Next, fifth one is the execution of predict. It gives the required output, like this. So the next one is the second machine learning algorithm, classification. So listen, participants, how many of you remember playing the game of 20 questions? So in this game, one person would think of an animal or a place or a famous personality. Others would ask a question to guess it. The game would go something like this. First person said, I am thinking of an animal. So other asked, does it has more than 5 legs? First person said, no. Other asked, is that wild animal? First person said, yes. Other asked, does it appear on the back of the Indian coin? So first person said, yes. Others said, is that a lion? First person said, yes, it is. This is exactly how we would create a decision tree for any data science problem. So now I am going to discuss some math behind this. So the decision tree is a classification. So it is used in this algorithm is called as a CART, that is classification and regression tree. It is one of the main machine learning technique. It is used to perform both classification and regression. So here the classification is the process of finding or discovering a model which help in separating the data into multiple categorical class. Regression, you know, that find the continuous real value. So here the structure of the CART model is, first one is that's the root node. The root node, the node that performs the first split. So in this case, the more than 5 legs, guess an animal example. In this root node, the first question is, does it has a 5 legs? The answer is either no or yes. Then here in this diagram, the root node is more than 5 legs. So the last node, that is the terminal nodes, lion, mosquito, honeybee, like that. So these nodes are call it as terminal nodes that predict the outcome, that are used to predict the outcome. Then branches that are represented by arrows connecting nodes. It shows the flow from question to answer. So many non-leaf nodes are there. These non-leaf nodes are used to make call it as decision nodes. This is the structure of CART model. Root node, terminal nodes, branches. Root node, first split. That is the node that performs the first split is called as a root node. Then terminal nodes means nodes that predict the outcome. So the math behind this decision tree is, to implement this decision tree concept in machine learning, we used one algorithm, that is R-part. In a previous case, we called the function LM. Here, I call the function R-part, R-P-A-R-T. Expansion for that is recursive partitioning. That means repeatedly partitioning the data into subsets. So here, and this algorithm, its result is, the R-part, its result is either a continuous variable or categorical variable. So this R-part, it produces one result. That result consists of a set of rules. That rules are used to predict the target. Like that. So it can be either produce continuous variable or categorical variable. In this algorithm, it acts as it produces a continuous variable, means we can call it as, that is the regression tree. This algorithm, it produces a categorical variable or produce some category, means we can say that that is a classification tree. So here the decision rules always produce two results, either yes or no, like that. So listen, here one small example is there. So in this example, this plot shows a sample data for two independent variables. One is X, another one is Y. Each data point is colored by the red or gray. So here, so CART tries to, our algorithm tries to split. So here the three splits happen. First one is the yellow color line. The second split is blue color line. Third split is based on gray color line. So here, in a first split, the X variable is less than 65. Like that. So listen, the first split test whether the variable is X. X is less than 60. Then our algorithm says the prediction, the particular point is red color. Then the second split checks whether or not the variable Y is less than 20. See this diagram? It checks whether the variable Y is less than 20. If the variable is less than 20, that is yes means it again one more split is there. Checks the variable x less than 85. Then our machine and our model says that our prediction is that is red. And the third split, that is suppose the second split y less than 20 is no means our model says the prediction is gray, like that. So listen, here one question is there, how the split is happen. So the split is there are many ways to control the splits. So for one of the best method is entropy. So it is it's a way to measure a impurity of an attribute. The next one is so in this tree, which attribute is act as a root? We need to select that. We need to identify that. Which one is act as a root? So for that, we need to calculate the information gain of each attribute. Which attribute information gain value is highest? Which attribute has the highest information gain value means that attribute will act as a root node. That is the main thing. So first, you understand. I think you understand this one. So many attributes are there. Many inputs variables are there. First, we calculate the information gain of each attribute. Which attribute has the highest information gain, that will act as a root node. That's all. The next one is how to execute this classification algorithm in R programming. So first one is installing the R platform. That's that. Then loading the data set. Then summarize the data set. Then build the model and make some prediction. The previous also same as to previous. So for first, how to load and summarize, that. To explain this classification, I used Irish data set. So either you choose the data set from a website through the URL, or sometimes that I keep the data set in local drive. So for that, I use read.delimiter. Then next one is one more function is there, that is summarize, how to summarize the data set. That means how we know about the attributes like that. So for that, we call the function dimension of the data set. Dimension of the data set. How to know about the dimension of the data set? By using one function dim, dim of Irish. It produces some result. That means the data set has how many, it has 150 rows and 5 attributes like that. So the second one is we know about, if you want to know about the type of attributes. So for that, I call the function apply of Irish, comma class. Class means it says about the response variable. So this is used in first Irish, first one is the data set, comma class. So this function, it says about the type of attributes. In our Irish data set, first inputs are numeric. The last attribute is the categorical one. So the next one is the summary of Irish. With the help of summary function, we can know about the statistical summary. That is mean, median, like that. So the first one is the dim function. It is used to give the with the help of dim function, we can know about the dimension of the data set, how many rows and how many attributes like that. Apply function, it is used with the help of that, we can know about the types of attributes, whether it is a numeric or character like that. Then third step is the install packages. To implement this classification algorithm, I first before I write the code, you have to install a package RPart. RPart stands for recursive partitioning algorithm. So the next one is we have to include that package by calling library function. So this is the data set. I'm going to use this classification process. So first one is the sepal length, second one sepal width, third petal length, fourth one petal width. Finally, this is a class. that is a species. I'm going to identify the given data. The unseen data is belongs to which class, whether it is a Setosa or versicolor or Virginica, like that. Totally the species. Finally, the response variable, it has 3 classes: Setosa, versicolor, and Virginica, like that. So for that, next step is model creation. How to create a model. So listen. Here I call the function rpart. Similarly, the first one is the formula. First argument says the formula. The second one is the data set, where it is available in a data set. The data set Irish is available in the variable data. So here the model is built like that. That means I am giving petal length and petal width. With the help of petal length and petal width, our model says the model predicts the particular species belongs to which class, like that. So this is the result is the developed model is assigned to the variable model. Then I call the function plot model. So here this output will be displayed in your RStudio after executing plot. Then next one is this is the source code for implementation of that classification algorithm. So here better you have to import the data set from the given URL. I think these codes are these source codes are available in OneDrive. So the first data set is import into the RStudio, and it is available in the variable Irish. The second step. So listen, the second step is that is I am going to display the first 6 attributes. So for that I call the function head of data set. Then third one is the, listen, in a website, if suppose if you are trying to import data set from web, means that data set, it has no field name, that no attribute names are there. So we need to assign some attributes for our data set. So for that, the first attribute, that means first column is sepal length, second one is the sepal width, then petal length, petal width, last one is the species. So for the third step, it is used to assign a attribute name for the data set. So next I am going to display the data set by call the function Irish, like that. Then I install the package rpart. After installing, we need to include library. So a library of rpart. Then the next line, the 6th line, that is 6th line says about the model prediction. Model development. So model development step. So here the model development, we always use the training data set. So petal length and petal width is the input. With the help of petal length and petal width, we need to find the species. So this developed model is available in the variable model. Then we need to build a data frame. So listen, so here one mistake is there. So data frame, we need the unseen data is created for petal length and petal width. So petal length is equal to 5.2 and petal width is equal to 2.0. Because this algorithm is going to classify the unseen species, whether it is belongs to Setosa, versicolor or Virginica, based on 2 inputs, petal length and petal width. So petal length is equal to 5.2, petal width is equal to 2.0. So this developed data frame is available. In the variable new data. Now the 8th line, that is predict. I use the predict function. So predict the developed model that is available in model variable, then our data frame new data, comma, the third attribute is very, very important one. So the third attribute is equal to type. Listen, this R part, either it will act as a classification or it will produce a regression output. Suppose in our problem, it is based on problem based on classification. So we have to type is equal to class. That means the prediction is based on classification. And then suppose if your data set, the same algorithm, it is we can use this algorithm in a house price data sets also. In that case, type is equal to, you need to give the value ANOVA, ANNOVA, like that. For regression, type is equal to ANOVA. For classification, type is equal to class. So after that, after prediction is over, the predicted result is available in the variable PRED. Now I am going to display the variable PRED. So the output will be like this. And that means the petal length and petal width. Petal length is equal to 5.2. Petal width is equal to 2.0. Now, that type of species belongs to which category? Iris, Virginica family. That unseen data belongs to Virginica family. This is the output of the classification using R part. So the next one is this is the sample to same program, but here so only small modification, same code, but in some modification in the model creation. So model creation, I include 4 arguments, 4 features: sepal length, sepal width, petal length, and petal width. This is one modification. So this line says, based on 4 features, I am going to predict the species. Then the next one is the next line, also performing some change. Here 2 unseen data are there. So first one is the sepal length is 5.3. Second one sepal length is 7.2. First one sepal width 2.9. Second one 3.9, like that. So here I am going to predict the class of 2 unseen data. So the result is the required data frame is constructed. Then the result is constructed data set is available in unseen. Now I call the function predict. Here model, first argument is developed model. Second one is the data frame. Third one is the type is equal to class. I am going to find the species belongs to which class. So finally, the output can be seen by calling the variable PRED. So listen, after executing this source code, we get the output Irish, Setosa. That means first unseen data belongs to Setosa. Second unseen data, it belongs to Irish, Virginica, like that. So the next one, the last one is the performance measures. So this is our prediction result. So in classification, Iris Setosa and Iris Virginica is the prediction result. In regression case, house price, that is produced the 29,000, like that, 29 lakhs. That is that real number is a predicted result. Now the performance measures. So in our hand, we have a classification problem, means the predicted, that is performances, analyzed by using the following matrix, that is a confusion matrix. With the help of confusion matrix, we can able to predict accuracy, precision, recall, and F measures. Suppose in our problem is the regression. Regression means with the help, we can measure the performance with the help of mean square error or root mean square error, like that. So the performance based, depending upon the problem, the performance measures may be varied. If it is a classification problem, means we use the confusion matrix. If it is a regression problem, means we use mean square error or root mean square error. So the first I am going to tell about the confusion matrix. A confusion matrix, it is a table that is often used to describe the performance of a classification model. So here, and the confusion matrix, it has some field values. That is four fields are there. So for true negative, false positive, false negative, and true positive, like that. That means actual says. That means in our training set, it says no. Predicted says no. Then this field is filled by, this field is called as a true negative. Then one says no. Predicted says yes. So false positive. This is called it as a false positive. Then actual data set, it says yes. Prediction result says no. That means, assume in this case, to explain this, assume one data set, that is whether rainfall, and it is rainfall is happen on tomorrow. Actual one says no. Predicted says no. That is represented true negative. Then actual says no. Predicted says yes, means false positive. Then actual says yes, predicted says no, that is says false negative. Then predicted says yes, actual says no, means that field is set to true positive, like that. So then accuracy is based on how can we calculate the accuracy. So accuracy is calculated by true positive, that is 100, plus true negative 50 divided by total 165. So the accuracy of the is calculated by using this formula, that is true positive plus true negative divided by total, that is 0.91. Then recall, this can be calculated by true positive divided by actual yes. That means 100 divided by 105. True positive divided by actual yes, that is 105. So that is 0.95. Then precision, true positive divided by predicted yes. So that is 100 divided by 110. True positive divided by 110. That is predicted yes. So we get 0.91. This is the way to measure the performance of the classification. The next one is the regression metrics. So here mean square error only I will show it in this slide. So the mean square error is the square of the difference between the actual and the predicted. So this error rate is minimum, means we can say that the performance is good, like that. So now I am comes to the conclusion. So in this session, we discussed what is machine learning and what are the needs of machine learning and some applications of machine learning. Then types of machine learning algorithms, that is supervised and unsupervised machine learning, reinforcement learning, like that. In a supervised learning, we need one guide. In unsupervised learning, we no need to guide, and we no need to have any guide. Reinforcement learning means the real time decision, that is in there is one agent is there. According to the agent, perform the robot navigation and like that. So the next we discussed regression tree. In a regression tree, to implement regression in R, we used linear model function. It is available in stat package, like that. So in to implement classification, we use the function rpart. It is so we call the function rpart. It is available in the package rpart. Rpart means recursive partitioning algorithm. It will act as either class. It will produce the classification result and also regression result based on the type variable, which will be specified in the predict function, like that. Then finally, we discussed the performance measures, that is confusion matrix and the mean square error. If our problem is classification means we use the confusion matrix. Our problem is a regression means we use mean square error or root mean square error, like that. So these are the some projects. So predicting gender of a person with the help of handwriting style, then predicting house price based on area, then predicting whether monsoon will be normal on monsoon season will be normal on next year, like that. We can also able to find the number of admissions on college, and also we can able to predict that the tumor is cancer cell or not, like that. So these are the some projects I am suggesting. So thank you. See any queries?
Dear madam, thank you very much for the presentation. And now I request the participants to ask your queries. The participants can ask your queries in two ways. You can type your questions in the chat window, or you can unmute your mic and you can directly ask the question. Geetha madam, if possible, go to the chat window.
One question is there, ma'am. Kamalam. So, ma'am, one question is there. That is bedroom. So you faced one sales price not found, ma'am. I think your data set sometimes the name is mismatched. So in a data set, it has a yes small letter means you have to use small letter in program also. So please check your attribute name. Is same in data set as well as your code. If both are same means then only we will get the output. Otherwise we will face this type of error. So text file, first copy the one text file, that means house price. One text file is available in OneDrive, that is sales. First you copy that text file in your local drive, that is a D drive. Then try the same code. Before executing that code, you have to confirm the data set attribute and also the code attributes both are same.
Dear participants, I have shared the feedback link in the chat window. I request all of you to enter the feedback before leaving the chat room. We will be sharing today's recorded video session and madam's presentation in the official web page of this workshop. I already shared the link to you, so you can use that video as well as the presentation for the future reference. Any other queries from the participants?
Shiba ma'am asked one query whether we have to install the package task before executing the program. Yes, ma'am. Before executing this program, you have to install the package and include the that package in your script file also. So in that packages, yes, STATS, then library STATS. For classification, before executing that, you have to install the package or part.
Any other queries from the participants? So now we reached the end of today's session. First of all, I thank Geetha madam for the wonderful presentation and the demonstration. Thank you very much, madam.
Thank you, sir.
Now I thanks my co-convener Andros madam for joining with me for organizing this event. Also, I thank the organizing team members, Engineer Varun, Engineer Tejos, and Engineer Anthony Kumar for their support and the hosting of this event. My heartful thanks to all the participants who all are active for this workshop, and patient also, because today we come across a technical issue, but you all kept patience. Thank you very much for your active participation. Once again, I thank all the members who joined for this fourth day of the online workshop. Thank you very much.